is alive property, and I can basically do a right line B. Is this thread alive? Then I can basically also find out uh, T dot, is it a background thread? You can see this. Return type of the background property is equally a Boolean value. So bool C is equal to this. And I can basically find out if this is a background thread or not. So without creating an object of the thread class, this is the way to create it. Okay. I will not be able to use any of the properties or methods. That's very, very basic behavior of object-oriented programming. You can say it is the thread alive? Yes, the thread is alive.
Okay.
Okay, and you can also see that is the background thread false. It's not a thread which is running at the background.
Okay.
Okay, it's false. What's the name of the thread? The name of the thread is basically, this is the name given, setting the name and
Okay.
getting.
Okay, that makes sense. So this one is newly created.
Is it fine now?
Sorry?
Should we move forward?
Yeah.
All right. Now let's see a static method. Okay. Now static method will use a static keyword, and static method should be called with the class name. That's a rule in C#. So we can call static and non-static methods on the execution of the thread. We can create that. To call static and non-static methods, you need to pass method name in the constructor of the thread start class. Okay. For static methods, we don't need to create the instance of the class. You can just refer it by the name of the class. Okay. Now, how do we call a static method? And if you want to call a static method inside a thread, you need to pass the method name in the constructor of the thread start class. How to use this? Okay, so we will see both calling a static methods and a non-static method. So this is where I've given, you can see it out here. Number two is this one, static methods. I'm making it as a startup project. And I'm going to basically call the program.cs file. This is how I've used it. You can see this. Okay, now this is one class. It's a public class. It's called my thread class. It has a static method. This is a static method up here. The static method is named as thread1. Okay, now what is this method doing? It is basically using a for loop which will run from 0 to 9. Can you see that?
Yeah.
It's basically going to print out 0 to 9. That's what it's going to do. Nothing else. Straightforward. Now, what I've done is that I've created another class called the thread example class. And this is where I've called the main method. Okay, this is where I've called the main method. And you can basically call the main method. I hope you know static void main, something like this. I've not used the string arguments out here. The main is just public. So you can call string args if you wish to. All right, that's the main method. So very interestingly, I've created two objects of the thread class. So this is the objects of the thread class, instance of thread class. So what does the thread class do? If you go to your basics, the thread class provides properties, the thread lifecycle. If you look at the thread class, provides properties to create and control the threads. Very important thing. To create and control threads. So that means I've used a thread class out here to create and control my threads. Now inside this constructor of the thread class, okay, if you look at this, the first program, straightforward. I've used the thread class object, but I've created the thread class object by calling the current thread property of the thread class. This is creating the object, and inside the constructor, I'm passing on the thread start class. This is the object of the thread start class. Now, why I'm calling that? If you go to your behavior out here, you are calling static and non-static methods on the execution of the thread. So to call static and non-static method, you need to pass method name in the constructor of thread start class. This is the thread start class object, and this is the constructor. So you are calling, this is what you are doing. If I copy this, this is nothing but you are calling the static method in constructor of thread start class. And what I'm calling a static method. How do static methods are called? They are called with the class name. So my thread dot thread one. So this is the constructor which you need to use in order to call static and non-static methods. And this new start in new, what is this one? This is a thread
Yeah.
start class. This is a constructor of the thread class.
Okay.
So you can understand that this is the constructor of the thread class. The constructor of the thread class is passing an object of the thread start class, which takes the constructor of the static or non-static methods. Static methods are called with the class name. That's the class. So I'm creating two threads out here. Thread class I used to create and control the threads. So I've created two threads. All right. And I'm calling a static method from this class.
I see.
So how do you call static methods and non-static methods? By creating a constructor of the thread start class. This is what you
Yes.
have to follow. Now, what is the start method used for? Start method is used to start. If you go back to basics, okay. What is the start method used for? It is basically used for the purpose of changing the current state of the thread or to runnable. So it makes it runnable. It will make the thread to run.
Makes sense.
So make the thread to run. This will make the second thread to run. All right. So let's see how does it react. Which thread is run? So remember, I cannot control the threads. One thread will run and end, other thread will start and end. So which is running first, which is running later on, you cannot control that. Now, how do you know you cannot control? Look at the result. Both the threads are calling the static methods by using the constructor of the thread start class. So both the threads is going to execute 0 to 9. How is it executing 0 to 9? That is the question. So based on that behavior, you will understand that, oh, I cannot control the threads. So that is why the output will be given out here. The output of the program can be anything because there is a context switching between the threads, which we cannot control. The context switching between the threads is not under our control. This will be controlled automatically within themselves. Let's run it. You will see the example result. I hope I have made this as a startup. Yeah. You can see 0, 1, 0, 1, 0. So you can see this is the first thread probably running. This is the second thread it started. So you can see it is not in sequence. Randomly, the numbers are coming. And you can see that 0 to 9 is printed out once for each of the threads. All right. So you cannot control the execution of the threads. That's what I was telling. This is the simple behavior to understand looking at the output, that the context switching between the threads happen automatically. I or you cannot control that.
Right.
Am I clear?
Yeah, that makes sense.
All right. Let's go forward now. Now, you can also use non-static methods. So for non-static methods, you need to create an instance of the class that you can refer it in the constructor of the thread start class. Obviously, non-static should be called with the reference variable or the instance variable of the object. You cannot use static methods can be called with the class name. Non-static method should be called with the reference variable or instance variable of the object. So let's see an example of that. So let's present out here in 3. You can see multi-threading non-static method. Okay, let's see that. You have the same myThread class. You have a non-static method out here. It's using the same for loop. Earlier one had a static method. This one is a non-static method. That's all. That's the only difference. Okay. You have the same for loop. It's going to basically run from 0 to 9. All right. I've created a thread example class where I've called the main methods. You have just not used the string args. You may use it, you may not use it, depends upon you. Okay, now 2 threads I've created. Now, if you want to call static or non-static method, you have to call it in the constructor of the new thread start class. How are you calling it thread1 method now? Look at how you're calling it right now.
Public void thread1.
So you're creating an instance of the myThread class. Then with the reference variable, the instance you're calling it. Okay. That's the difference between this static method where you don't need to create an instance of the myThread class. Directly calling it the class name.
You can directly refer. Okay.
All right. Here, if you want to call a non-static method of the myThread class, create an instance of this class. That's what I've done. With the instance reference empty, you're calling the methods. In the constructor of thread start class, which is the constructor of again of your thread class. Okay. Now the output will be same. Output of this program can be anything because there is a context switching between the threads I cannot control. That the thread will understand it. So make this as a startup project. So let's run this. Do you see 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then 2, 3, 4, 5, 6, 7, 8, 9. So which thread is running? I don't have any control. The switching of the context of the threads is automatically done within themselves. All right.
Nice.
That's calling a non-static method.
So I have a general question. I always forget what's the difference between a static method. Like what exactly?
Okay.
I just want to make sure I remember.
Okay, so let's say basically I create a static method. So static method will have a static keyword.
Right.
All right, I can give a method name, let's say addition. Okay. And where's the class ending namespace class? Yeah. Addition method void namespace cannot be directly containing. Okay, it should be inside a class. So I probably can make it inside this class only. Okay, method should be inside a class. This is another method inside this thread example class. Or you can call this method if you wish to create it inside myThread class. This is where that's ending. So addition is a static method, and let's say it does an addition of 10, and you have p, and then you can say that nc is equal to a plus b and cwc. So how do you call this static method? If you want to call this static method, the rule is that you have to call with the class name. So what's the class? myThread. So for example, myThread is the class name. So myThread class dot addition method. So when you call the addition method, you're calling with the class name and you pass off the value of the parameter. integer b, let's say 200. All right. So that's the same thing that I've done in the constructor of the new thread start class.
Right.
This is basically non-static method. Remember that. Okay. This is non-static method. And I can create a non-static method here also. Non-static method will not have the static keyword. I'll call it a subtraction.
Mm-hmm.
All right. And I'm basically going to subtract this. All right. So how do I call the non-static method
So
inside this class? So I have to create an instance of this class
you
instead of
have
my thread class. So with that instance, I can call the subtraction method. So when you call this, you're going to basically define the value of b. Let's say 2. All right. That's the same thing I've done out here. You can see.
right.
Non-static methods are called with the reference variable of the object of the myThread class. All right. So when I run this right now, you will see the result of addition and subtraction separately. And that's, you can see where the addition and subtraction is coming, 210. Or I can basically make things a bit easier for you. I can start 2 more threads. Thread T3. T3, what's T3? Is equal to new thread. And here I do create an object of the new start class. And this object is going to take my thread, this one. That equals makes big lives easier. Structures I'm calling. Same thing. Let's remove this to make life easier.
Okay.
Well, this is 10 minus 200, that shall be minus 190. That is, so this has to be called, this is non-static. So this has to be called with the reference variable of the object. Reference variable will be this empty. Empty dot subtraction.
That makes sense.
All right, and then I have to start these threads. Okay, this I'll call this to make it a but tangible subtraction. That's it. And that's going to be addition method. All right, and let's run this. We will start this first. Start this t3.start. Started, we cannot make it in runnable state. All right, let's run this now. You see where the addition methods have been running. This is the addition method and subtraction method been called. Okay, there is some problem. Let's not call it.
Yeah.
Now you can see where it is getting called. All right. Now you can see that both the threads are supposed to, thread 1 and 2 is supposed to give you 0 to 9. Thread 3 and 4 is going to give you addition and subtraction methods. Now where it is coming, not under my control. It can come anywhere.
Right.
Thread is executed anywhere. So you can see the first thread is throwing a value of 0. Then the second thread is also throwing a value of 0. Then 1, 2, 3, 4, 5, 6, 7, 8, 9. Then addition, subtraction method threads. Then again 1, 2, 3, 4, 5, 6, 7, 8, 9. All right.
Got it. But is that like the main thing with static? Is that with static methods you don't have to?
Main method is always static because that is how the
Oh.
architects have created it.
Oh yeah.
That is called the entry point or the compilation point.
Oh wait. Well, when I said main, I meant like in general, like the difference between static and non-static classes is like when you call that method, you don't have to make an instance.
Yeah, static methods do not require instance creation.
Okay.
Static methods can be called with the class name. Non-static methods needs an instance.
Okay. Makes sense.
All right. All right, let's go further now. So we have seen example of non-static. Now we'll see example of, this is example, thread example performing different tasks on each thread. It's example where different tasks are performed on each thread. And that's defined in fourth one. This is the fourth one. So let's make it at a starter project. And let's open this. So it's a multi-threading concept performing different tasks on each thread. All right. Now this is a my thread class. It has two static methods, you can see. Okay. Method, the first static method is called thread1. The second static method is called thread2. Thread1 gives a printout of task1. Thread2 gives a printout of task2. Static method should be called with the class name. So this is a thread example class. Main method is out here. Now you create two threads. This is thread class is used to create threads. You create a constructor of the object of the new thread, and you're calling the thread1 and thread2 methods by the class name because these are both static methods. So call it with the class name inside the constructor of new thread start class. All right, and we start the, make it runnable. You make the threads runnable. Okay, so what is the output of this? Output is of this is that if you look at the thread 1 is being called first, thread 2 is being called second in the second thread. Okay, so what is the output of this? So what is happening out here, that you're performing different tasks on each thread. This task is performed on thread 1. This task is performed on thread 2. Different task on each thread. This is basically performing the thread 2 method.
Right.
Thread 1 is performing the thread 1 method.
This is just going to print task 1 and task 2.
Yeah.
Oh.
So each thread has been given a particular task. So that is what performing individual task on each thread. That is what this particular example is going to throw you. So this is going to throw, when you start it out, this is going to basically start thread 1. So this will throw out task 1. When you start thread 2, it's going to throw out task 2. That's the printout of these two methods. Run this. Task 1 and task 2. You can see that. Now, if I basically create one more method, for example, let's create non-static method. Call this a thread 3. And this will be task 3. For non-static, we need to create an instance of this class first. And the non-static method should be called with teeth. Okay, and this should be called with empty. And you can start this t3 dot start. So the third thread is going to perform a specific task again. What is the task? To print out task 3. This method is a specific task of thread 3. Let's run this now. You can see. So performing different tasks on different threads. That is just to show you that. Clear? Is it clear?
Yeah, makes sense.
All right. Now let's take an example of sleep method. What is the sleep method used for? To
It's you.
suspend a thread.
Right.
So it's basically used to suspend a current thread for a specified time period. The time period will be in milliseconds. So other threads gets the chance to start execution. So other threads will get a chance to start your execution. That's an example of it. If you go to fifth one, that's your sleep method. Make this as startup. All right. So again, a class called as myThread class, a non-static method, and this is going to run from 0 to 9. It's going to print out 0 to 9, and here is where the sleep method is used. Okay. Here is where the thread dot sleep. So you can see thread is a class. Sleep is a static method. So static methods are called with the class name.
Ah, I see.
All right. It's internal method of the thread class. All right. There's a class called as thread example. That's a main method. Now I've created two threads with the thread class object, and the constructors in the thread start, I've called these thread1 method. Both the threads are called with thread1 method. You can see that thread1 and thread2 called with the same non-static method. So both these methods are implementing the sleep. Okay. So what is going to happen?
What's gonna happen is
What's
it's
going to happen
gonna.
is that both these threads will sleep for 200 milliseconds.
No.
Both is going to sleep about 200 milliseconds. I can run this and show it to you. See that 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9. So that means what is the behavior of sleep method I've given? So other threads can get the chance to start execution. Now, since I've implemented the same method in both the threads, both have the same methods being called. So the sleep method is used in both the threads. If I comment the thread class sleep method, what is going to happen? Then this is going to run, these threads are going to run randomly. There will be no stoppage. So 0 to 9 will be printed out randomly. So which thread is running, I do not know. So let's run it. See the result now. You can see 0, 0, 1, 2. Which thread is running, you can see this, right? This is the first thread, this is the second thread. Then probably first thread, 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 then the second thread, one, second thread, two, second thread, three.
Yeah.
Now the moment I implement the thread.sleep method, which is used in both these methods, used in both these threads. So what's going to happen? This is going to stop the thread for 200 milliseconds, so that the other thread starts executing. Now the other threads is also not executing because the other thread also I've used the same sleep method. Okay. Now what I can do is that I can create another method. Same method. I'm not going to use thread.sleep. This will be thread2. And call thread2 out here. Now this is called with the thread1 method. It has sleep. Here in the thread2, which is defined in second thread instance, this does not use the sleep method. So what will happen when this is sleeping, when this thread is sleeping for 200 milliseconds, this thread will start executing. Run this. See the difference. See, it is slow, it is executing slowly. Which one is executing slowly? This will execute slowly. So if you see certain results are slowly getting executed, certain results are coming fast. The result for thread 2 method will come fast. Result for thread 1 will execute slowly, and you can see it from the execution only. See that. This is thread 1 getting executed. Thread 1
Yeah.
method.
Yeah.
So when the thread 1 is going for a sleep mode, thread 2 starts executing.